Welcome friends. In this video lecture we will learn synthesis using T flip-flops. That is synthesis of clocked sequential circuit using T flip-flops. So here we will take up an example of designing a 3-bit counter using T flip-flop. So as we all know, a counter is a sequential circuit that counts through a specified sequence. So if an n-bit binary counter, it consists of n flip-flops that can count in binary from 0 to 2 power n minus 1. So if you take a 3-bit counter, it can count from 0 to 2 power 3 minus 1. So it will be count from 0 to 7. So the counting sequence with respect to the state diagram is shown here. So it starts with 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then it goes to 1, 1, 1. After counting 7, then it again goes back to 0, 0, 0. Now, when we are going to use T flip-flops for this design of counter, we need to go back to the T flip-flops design, that is basic of T flip-flop operation based on its excitation function, excitation table. So if present state is Q, that is Q of T is 0, if the next state Q of T plus 1 is equal to 0, that is both present state and next state are 0, 0, then the input T for that flip-flop will be 0. If present state is 0, the next state is 1, the T value will be 1, T input is 1. If present state is 1, next state is 0, T input is 1. If both present state and next state are 1, 1, the T input is 0. So for designing or synthesis using T flip-flop, the excitation table is very important. So this excitation table is derived from the basic characteristic function of the T flip-flop. Now we can go for the state table representation of the corresponding state diagram, which is shown in the previous slide. So we are having tabular format of present state. Each flip-flop is named with A0, A1 and A2. The same thing, what is the next state of flip-flops A0, A1 and A2 is given in the next column. So if present state is 0, 0, 0, the next state is 0, 0, 1. That is flip-flop, if the flip-flops are count, that is present state is 0, 0, 0, the next count is going for 0, 0, 1. If the present state is 0, 0, 1, next state is 0, 1, 0, that it counts 2. Present state is 2, next state is 3. Next, present state is 3, next state is 4. Present state is 4, next state is 5. Present state is 5, next state is 6. Present state is 6, next state is 7. If the present state is 7, next state is 0. That is, it counts 0, 1, 2, 3, 4, 5, 6, 7 and goes back to 0. Now, how to find the flip-flop input equation? There are 3 flip-flops, so 3 inputs will be there because we are using T flip-flop for the design. So it is T input is named with flip-flop description TA0, TA1, TA2. So now we need to find what is the value of the T input for each flip-flop. So that is where the excitation table is used. So if a present state is 0, next state is 0, T value is 0. So we are going to go back to the state table. So for filling the T inputs, so first we will fill for TA2, that is TA2 for the flip-flop, third flip-flop. Present state is 0, next state is 0, T input is 0. Second, present state is 0, next state is 0, T input is 0. For third one, present state 0, next state 0, input T is 0. Fourth combination, present state 0, next state is 1, so the input T is 1. Fourth combination, present state is 1, next state is 1, but input T is 0. Fifth one, present state is 1, next state is 1, again 0. Present state is 1, next state is 1, again 0. Finally, present state is 1, next state is 0, T input is 1. Similarly, the same thing, the excitation table is used for filling the next 2 flip-flops by comparing the present state and the next state of the corresponding flip-flop. So in this way, we have completed the state table. Now we need to use the K-map for simplified Boolean function, arriving at the simplified Boolean function for TA0, TA1 and TA2. So it is shown in the next slide. So TA0, all the values of the combination of present state, next state is 1. So all the ones are recorded in the each squares of the 3 variable map. So if all these ones, 8 ones are combined, the value is 1. So the logic 1 high input should be given for TA0. Similarly for TA1, these are all the squares which produces 1s, so we can combine all these 4 ones to get A0, and for A0, TA, that is TA2, these 2 ones can be combined to give A0 and A1. Now we got the simplified Boolean function for the corresponding TA inputs of each flip-flop. Now we can go for logic diagram. So logic diagram is constructed through the basic flip-flop symbol. So this is the 3 flip-flops we are using, 3 symbols. We need to draw it, rectangular box with the T inputs, and because this is synchronous sequential circuit, the clock is given to all flip-flops simultaneously. So the clock input is given. Now as per the Boolean functions, we got TA0 is 1. So TA0 is given directly, TA0 input is given directly to logic 1. TA1 is equal to A0. A0 means the output of the first flip-flop, that is Q output of the TA0. So that TA0 is given to the input of the second flip-flop, that is T. Next, what is the input for TA2? We got A0 into A1. So this is a product term we are having. So AND term we are having. So we need to use an AND gate. So here to get A0 as one input and A1 is the Q output of the TA1 flip-flop. A1 flip-flop. So that output is given as another input of this AND gate, and the output of this AND gate is given to the T input of the third flip-flop, that is A2. So this is the way with which the counters are designed, synchronous counters are designed. Always we need to start with the corresponding counting sequence. For the counting sequence, which flip-flop they are going to use, that flip-flop is going to be identified. For that flip-flop we need to have the excitation table. So once you got the excitation table, from that we need to derive the state table. After deriving the state table, we need to reduce the simplified expression for each input. For example, if it is either can be T flip-flop or it can be a JK flip-flop. If it is going to be T flip-flop, it is straightforward because Q of T plus 1 is equal to D. So it is very simple. What are all the next state values of each flip-flop? That will be the input for the D. Each flip-flop D inputs. So that will be simpler design than T and JK flip-flop. Then after reduction of simplified Boolean function, then we need to draw the logic diagram in this fashion. Thank you.